This is a quick video to go over the structure of the Earth. Now, the first question you have to ask when scientists tell us that we know what the internal structure of the Earth is how on earth do you know if we've never been down there? Because when you have a look, up here we have the crust that we live on, and guess what? We haven't even broken through that crust yet. It ranges from about 7 to 30 or 50 kilometers thick, and the fact is we actually haven't even been able to travel halfway down through that crust to see what's underneath. So when it comes to what's below the Earth's surface, an awful lot of it is actually assumed knowledge based on evidence that we've collected, but we actually haven't been down there to see for certain. Now, the way scientists have tried to figure this out is essentially by earthquakes and a few other pieces of evidence. So we'll just have a quick look at the layers of the Earth and what we're calling them, and then we'll have a look at the evidence that scientists have used to try and figure out what's actually inside the Earth. So the first layer is the one that we know best, and that's this one out here. That's called the crust. Now, that's actually not a solid piece of crust. As we've actually seen in the videos that we've been watching, it's actually pieces of solid crust floating on what we think is a semi-solid mantle underneath. So when you actually look at this crust, it might seem thick to us because we're digging and digging and digging and we never get down to any lava or anything. But if that was, say, the size of a basketball, you would find that the crust would essentially be only the thickness of a piece of paper. The crust itself is very, very thin compared to the rest of the Earth. Now, underneath the crust is something we call the mantle. Now, the mantle, as far as we know, is what we call semi-solid rock. In other words, it's mostly solid, but it has a lot of patches of liquid in it, and it is definitely able to move from what we can understand. So we actually have a whole heap of half molten rock in this area that is able to move around and affect what is happening up on top here. The next layer that we have is called the outer core. Outer because it's on the outside of the core. Now this here we actually think is liquid, and it's got an awful lot of heavy elements in it. The last one here is what we call the inner core, and we are pretty darn sure that it is solid iron. Now we're going to be getting to why we think this in just a moment. So there are those notes there. Now you might ask why scientists think they know this. Well, it essentially comes down to earthquakes to begin with. When an earthquake happens, say it was happening here, the waves from that earthquake spread out, or should spread out, through the entire Earth because they can go out in all directions. It spreads all of the energy waves from it all over the Earth from that point because they can actually travel through the Earth. But when scientists actually try and measure them where they come out at the other side of the Earth, they actually found that not all of the energy waves were making it through. And they were able to make some deductions about that. Now, number one, you have to realize I've drawn two types of lines here going away from the earthquake. That's because there are two types of waves that earthquakes release, S waves and P waves. Now, you don't have to understand anything much about them other than S waves can't travel through liquid. They cannot go through liquids. And P waves can, but they will often be slowed down and bent if they try and go through liquids. So if they try and go through liquids, they might be going like this, and as they slow down, their track will actually bend in a different direction. So what the scientists found was this. There was a whole heap of S waves that weren't arriving at their destination. So say it's this one here. This one here, the S waves would reach. These waves would reach over here, but down here there was a whole heap of S waves that weren't reaching at all. And that's because when they go down here they must be hitting a liquid somewhere which blocked them so they couldn't keep going any further. And scientists found this happening all around the world. So it actually looks like this. The S waves were actually blocked, which meant that there must be a layer of liquid there that was stopping them from going any further whenever they tried to go deep within the center of the Earth. So that allowed us to make an assumption about what is down deep, even though we haven't been able to get down there. The other thing they noticed was that the P waves that were going through were actually getting bent. So instead of continuing on the trajectory that they should have if they'd been able to go in a straight line, and it looks curved because we're going through the center of the Earth here, they actually ended up getting bent and therefore turned on a different trajectory, which allowed scientists to realize that these layers in here and the ones in the inner core here are extremely dense layers. Now, the last thing we need to discuss is how we think the inner core here is a solid piece of iron. And that comes into account when we look at the fact that there is a magnetic field around the Earth. Not a small one, but a huge one that actually reaches out into space like this. And if it wasn't for this magnetic field, we wouldn't actually be protected from the cosmic radiation that the sun puts out. So this magnetic shield here can only be produced by a very magnetic substance, which is iron. Now, iron itself is only magnetic in solid form. When it's a liquid, it actually doesn't have magnetic properties. So therefore, scientists have deduced that the center of the Earth must be made of iron because of the magnetic field, and it must be solid because that's the only state that iron forms a magnetic pull. The only other thing I haven't mentioned is the fact that we know that this is liquid in here and here, because when there's a break in the crust, what pops up but liquid magma, which then we call lava. So if that's coming from underneath, we know there must be liquid molten rock underneath. Together, that's enough for you now to fill in your worksheet on the structure of the Earth and the evidence that we have in place to try and help us deduce what is down there, even though we haven't been there.